Hey everyone, Dr. Yu here. Today we're going to look at how to balance chemical reactions. I know this is a topic that a lot of students struggle with, and I don't blame you because this can kind of get a little bit complicated. But hopefully what I'm going to talk about today will help you get used to kind of balancing chemical reactions so it becomes a little bit easy as you prepare for the TEAS. So this is the topics we're going to cover today. First, I'm going to go over some of the basics. For example, what reactants are, what products are, and then we'll go over two very important terms, subscripts and coefficients. So you absolutely have to know what these two terms are before you can balance any chemical reactions. And then we're going to go over two examples of chemical reactions and then go through the steps to balance them. On the last slide, we will have some practice problems for you guys. Now, if you already know these basics, then feel free to jump ahead and then just look at the steps on how to balance chemical reactions. Okay, we all know that chemical reactions are the processes where one or more substances are changed into new substances, right? This is very different than a change in the state of matter, right? For example, water changes from liquid water to ice. The substance is still the same, still water, right? But the state, the form is a little bit different. But in chemical reactions, keep in mind that the substances will be changed into new substances. However, matter can either be created or destroyed. So that means even the substances are different, right? At the beginning and at the end of the chemical reaction, you should have the same number of atoms. So the number of a particular atom should be the same at the beginning and at the end of the chemical reaction. So if you start with, let's say, 4 carbon atoms, then you should end up with 4 carbon atoms. But of course, the substances that contain the carbon atoms are going to be different, right? You may have, let's say, carbon dioxide on the reactant side, and then you end up with maybe, so we'll have to change this to 6 carbon, right? So we're in the example that we talk about. And then at the end, if you have, glucose, right, you should still have 6 carbon atoms. All right, now I did mention a term, which is a reactant, right? Reactants refer to the starting materials in a chemical reaction. So if you look at this example, carbon reacts with oxygen, and that generates carbon dioxide. Carbon and oxygen will be considered reactants. And then the products are materials present at the end of a chemical reaction. So in this case, carbon dioxide will be the only product in this chemical reaction. Okay, so when we talk about balancing chemical reactions, I will probably say, the reactant side or the product side, and that's what I mean. Okay, the reactant side are the beginning of the chemical reaction, and the product side is the end of the chemical reaction. All right, now let's look at subscripts. So subscripts are really just numbers, right? They are numbers of a particular atoms in the chemical formula. For example, in calcium chloride, the subscript for calcium would be 1. Now, here's the rule. If the subscript is 1, then we do not write it out. You can just leave it blank, but you should know that the subscript is 1, right, if there's no number there. And the subscript for chloride ion, for chlorine element, is 2. So those are the subscripts. Now, sometimes you will see subscripts within the parentheses and subscripts outside a parenthesis. So in that case, when you calculate the number of an atom, you need to multiply the two numbers. Okay, I have another example here, aluminum sulfate. So you can see the subscript for aluminum is definitely 2, right? That's pretty straightforward. But then when you look at the sulfate, you can see that there's a 4, that's a subscript within the parenthesis, and then you have a 3 right outside a parenthesis. So now you need to multiply the two subscripts. Right? So the subscript for sulfur within the parenthesis is 1, right? Because you don't see a number there, so that indicates it's 1. So you're going to multiply 1 by 3. So 1 times 3, that's 3 sulfur atoms in this chemical. And then oxygen, that's going to be 4 times 3. 4 times 3, so that's 12. So aluminum sulfate has 3 sulfur atoms and 12 oxygen atoms. All right, now let's practice a little bit. You can pause the video here and then try to finish everything, and then resume the video. Compare your answers to mine. So for the first one, barium hydroxide, barium is going to be 1, right? So the subscript is 1, so that means there's 1 barium atom. How about oxygen? So this is where you gotta multiply the 2 subscripts, right? So oxygen is going to be 1 times 2, that's 2. And same thing for hydrogen, 1 times 2, that's 2. Okay, next one, calcium. So calcium is 1, okay? And for hydrogen, remember you have to multiply the 2 subscripts. So 1 times 2, that's 2. For carbon, same thing here, 1 times 2 is 2. And oxygen has subscript of 3 within the parenthesis and 2 outside the parenthesis. So 3 times 2, that's 6. Okay, last one. This one's probably the most complicated one. For mercury, that's a subscript of 2, so 2 mercury atoms. For carbon, 2 times 2, that's 4. Hydrogen, 3 times 2, that's 6. And oxygen, 2 times 2, that's 4. Okay, so that's all about subscripts. Next, we're going to look at coefficients. And really, coefficients are the numbers that you need to figure out when you balance chemical reactions. A coefficient is just a small whole number. Make sure it's a whole number. So you can't have like a 1.2 or 3.5. No, it's either 1, 2, 3, 4. You know, it has to be a whole number. So this is a number that's placed in front of a chemical formula in a chemical equation in order to balance it. And again, remember the rule is the number of atoms should be the same on both sides, right? Both in the reactants and in the products. When there's no coefficient, if you look at the chemical reaction over here, see there's no coefficient for methane or carbon dioxide. That means the coefficient is 1. So very similar to subscript. If you don't see a number, just assume it's 1. When balancing chemical reactions, like I said, you are changing the coefficients, right? Those are the numbers you need to figure out. And you can only change or adjust the coefficients. Never, ever change the subscripts. Because if you change the subscripts, you are changing the chemical, right? If, let's say, I have methane here, and when I balance the chemical reaction, I can't really have 4 hydrogen here, so I'm going to change it to 2. Then this chemical is not methane anymore, right? So do not ever change the subscripts. You can only change the coefficients, the numbers that are in front of the chemical formulas. All right, so that's coefficients. Now let's go over 2 examples. So these are the major steps. I got the information from liberal texts for chemistry, but it's really similar to how I usually balance chemical reactions. For example, I usually identify the most complex substance. So what does it mean? What is a complex? What's the most complex substance? That means the one with the largest number of different atoms. If you look at this chemical reaction, you see number 7, number 16, right? They're much, much larger than number 2 or number 1. So this is going to be the most complex substance. All right, now don't worry about the letter L or G. That just indicates the state of that particular chemical. So L stands for liquid, G stands for gas. Okay, now once you identify the most complex substance, now you can adjust the coefficients, and you're going to adjust the coefficients based on the most complex one. So I have a 7 carbon right here. So 7 carbon. So let's indicate the 2 sides. So this is the reactant side, and that's the product side. So if I start with 7 carbons, that means I gotta have 7 carbons in the end, right? And only carbon dioxide has carbon. So that means I need to give carbon dioxide a coefficient of 7. So now I have 7 carbon, and now carbon is balanced. Okay, next, let's go to hydrogen. 16 hydrogen. And when you look at the product, let me write it here, 16 hydrogen. When you look at the product, only water has hydrogen, right? So what's the coefficient that you need to give to water to get to 16? And hydrogen already has a 2 there. So 16 divided by 2, that's 8, right? You can check, right? You put 8 here, 8 times 2, that's 16 hydrogen. All right, now we're going to balance whatever is left. Okay. So let's see. We have some very large coefficients on the product side. So you can see once you add these numbers for oxygen, it's definitely going to be larger, right, than the number of oxygen atoms here to start with, right? So this is only 2 oxygen atoms. And for carbon dioxide alone, you already have 14 oxygen, right? 7 times 2, 7 times 2, so that's 14. And then over here, you have 8 oxygen. So that's a total of 22 oxygen. So you can see this is a much larger number than whatever this subscript is, right? So we are going to balance oxygen using this very large number. So on the product side, we have 22 oxygen atoms. So we need to get to 22 on the reactant side. So how do we get to 22 oxygen? There's already subscript here. So 22 divided by 2, that's going to be 11, right? So again, double check, 11 multiplied by 2, so that's going to be 22, right? So now everything is balanced. Okay, number 4, double check your work. So even though you're pretty confident about your numbers, it doesn't hurt to double check, right? So look at the reactant side. So you have 7 carbon, hydrogen 16, and oxygen 11 times 2, so that's 22, good. And look at the product side, carbon only here, so 7 carbon, 16 oxygen, and 16 hydrogen. And for oxygen, you have 7 times 2, that's 14, and then you have 8 there, so that's 22. So everything is balanced. Now let's look at a more complicated example. Now in this case, you are going to have to deal with polyatomic ions. So what are polyatomic ions? Poly means many, right? And then you know what atomic means. So these ions consist of multiple atoms. Okay? If you look at, let's say, chloride ion, that's only 1 atom, right? But when you have, say, nitrate ion, it consists of nitrogen and oxygen, right? So it has multiple atoms. So this is an example of a polyatomic ion. Now, when you see polyatomic ions in a chemical reaction, make sure you treat the entire group as 1 unit. So you're going to treat NO3 as 1 unit. So when you balance the chemical reactions, you are going to try to balance the number of NO3. So you don't do number of nitrogen and number of oxygen. No, you do not separate them out. You treat them as 1 unit, 1 group. So if you have, let's say, 2 ions on the reactant side, then you got to have 2 on the product side. Okay. All right, now let's look at this chemical reaction. So again, we're going to follow the procedures here. First, let's identify the most complex substance. So to me, the number 2s will be the most complex substance. So we probably can just start with lead nitrate. And I'm going to start with the nitrate ion because it has the highest number here, right? It has 2. So you have 2 nitrate. That means on the product side, you also need 2 nitrate. So how do we do that? We will just give this a coefficient of 2, right? So now you have 2 nitrate ions. Okay, that's good. Now, So what I like to do is I like to balance the product side, and then I will use the big numbers on the product side to kind of go back and balance the reactant side to readjust the coefficients on the reactant side. So now you have a 2 sodium. So that means you got to have 2 sodium on the reactant side, right? So right now you have a 1 sodium. The subscript is a 1. So you need a coefficient of 2, right? So now you have a 2 sodium ions. Sodium is balanced. Now let's look at chloride, right? Because now you have 2 chloride there. And when we look at the product side, see, chloride already has a superscript of 2. So you don't need to do anything about chloride. It's balanced already due to the adjustment of coefficients. So now we just need to make sure that lead is balanced. You have a 1 lead on the reactant side, and you have a 1 lead on the product side. So lead is also balanced, right? Again, you do not need to do anything. And this kind of happens to a lot of chemical reactions. If you do everything correctly, oftentimes after you adjust, 2 to 3 things, everything else will be balanced. So you actually do not need to adjust anything. You can just keep the numbers. All right, so let's double check. We have a 1 lead, check. We have 2 nitrate, check. We have 2 sodium, check. We have 2 chloride, check. There we go. And then let's look at the product side. Do we have 2 nitrate? Yes, because of this coefficient of 2, check. We have 2 sodium, we have 1 lead, and then we have 2 chloride ions. Okay, so everything is balanced. Okay, now I hope that this is helpful. Now it's the practice time. Here are 5 practice problems. So again, if you need time, just pause the video and then come back when I review the answers. All right, now I'm going to show you the answers. The first 3 are relatively easy, and they do not involve polyatomic ions. And the last 2, you can see that it's a little bit more complicated, and there are a lot of polyatomic ions here. And there is a special thing about these last 2 chemical reactions, which I'll talk about when we get there. All right, now when you first start learning balancing chemical reactions, you may want to kind of write out the number of atoms on each side, right? So you can do reactant side and product side. So for the first chemical reaction, this one has the highest number, right? Chlorine has 2. So you have 2 chlorine atoms or 2 chloride ions. So that means you need to have 2 on the other side, right? So we're going to give it a coefficient of 2. So now for chlorine, it's balanced. And that leaves a magnesium. So you can see this is a 1, because again, if there's no number, that means it's 1, and that's 1. So you have a 1 magnesium atom on both sides. So that's balanced as well. So you're done with the first chemical reaction. Now for the second one, it's a little bit special because when you look for the most complex substance, you will see that this one has the highest number, right? It's got 3 hydrogen. And on the reactant side, you have a 2 hydrogen. So how do you balance that? You can multiply those 2 numbers. So 2 times 3, that's 6. So you want to reach to 6 hydrogen on each side. So how do you get to 6 hydrogen on the product side? You need a coefficient of 2, right? So 2 times 3, that's a 6. And on the other side, you need a coefficient of 3. So that's, 3 times 2, that's 6. So again, when you see this type of example, if you have a number 2 and number 3, you don't know exactly what to do, multiply them, and that's the number that you try to get to, right, for each side. So you want to get to 6 hydrogen on the product side and then 6 hydrogen on the reactant side. Okay, now that leaves us a nitrogen. So over here, you have 2 nitrogen. On the other side, you also have 2 nitrogen. So that's balanced, right? And again, that's really just a coefficient of 1. So like I said earlier, a lot of times if you do things correctly, you only need to balance a part of the chemical reaction or part of the atoms, and then the other atoms will be kind of naturally balanced. Okay, last one. So this is the most complex substance. We need a 3-chlorine. So we're going to give it a coefficient of 3. So now chlorine, this one has more atoms, so I'm going to write it out. So chlorine, have 3. You also have 3 chlorine on the other side. And now you need 3 lithium on the reactant side, right? So we'll give it a coefficient of 3. So now lithium is balanced. How about aluminum? This is 1, this is 1, so it's balanced, right? We don't need to do anything extra. There you go. So let's give it a coefficient of 1. All right, you can see that I tend to kind of go back and forth, right? So I will try to balance the one that has the highest number first, and then you can kind of go between the product side, the reactant side. It doesn't matter which side you go first, but usually you go whichever side you see the highest number after each adjustment. Okay, now let's look at the last two. The last two has polyatomic ions. For example, NH4, the ammonium ion. And remember, we need to treat this ion as 1 unit, right? We do not count 1 nitrogen or 4 hydrogen. We treat NH4 as 1 unit. So if we have 3 NH4 on the reactant side, then we need to get to 3 NH4 on the product side. Now, there's an exception to this chemical reaction, and that's the hydroxide ion. And that's because you have hydroxide ion on the reactant side, but when you look at the product side, there's no hydroxide ion, right? There's only water. So in that case, we will not treat OH as a 1 unit. We are going to kind of count and balance hydrogen and oxygen separately as a separate atoms. Now you can ask, so how come we don't do that for NH4 or phosphate PO4? That's because you have NH4 on both sides, right? And you also have PO4 phosphate on both sides. So when you have the polyatomic ions on both sides, then you treat them as 1 unit. If you only have them on one side, then you will balance each individual atoms. Okay. All right, so it looks like this one has the highest number. So we have 3 NH4 on the product side. So we need 3 on the reactant side, right? So we can achieve that by providing a coefficient of 3. Okay, so now the ammonium ion is balanced. So what do we do next? Now you can see next, the atoms that have the highest number is going to be the OH, right? Because OH has a coefficient of 3. And also this hydrogen has a very high number as well. So we're going to try to balance oxygen and hydrogen next. So we mentioned that we're going to kind of balance oxygen and hydrogen separately. We do not treat them as 1 unit. So that means we have 3 oxygen, right? 1 for oxygen, 1 for hydrogen. So 3 times 1, so that's 3 oxygen. And 3 times 1, so that's 3 hydrogen. Now, don't forget that you also have a hydrogen here, right? So you need to include that as well. So you have a total of 6 hydrogen. So that means we need to get 3 oxygen and 6 hydrogen on the product side. So all the hydrogen and oxygen end up in water, right? Again, we do not count the oxygen here because PO4 phosphate, that's 1 unit. Okay, we will balance PO4 as a group. We do not separate out phosphorus or oxygen. Okay, so in order to balance oxygen and hydrogen, we only need to find the correct coefficient for water on the product side. Okay, so what coefficient do we need? Water has a ratio of hydrogen to oxygen 2:1, right? And then over here, you need 6 hydrogen, 3 oxygen. That's perfect, right? That's a 2:1 ratio. So we just need to give the coefficient of 3, right? So now you have 3 times 2, that's 6 hydrogen, and then 3 times 1, right? That's 3 oxygen. So it's balanced. Now again, over here, that should be 1, 1, and that's perfect. We're done. Now, how about you do the last one on your own if you didn't get it right the first time? So pause the video and come back when you're done. Okay, for this chemical reaction, very similar, right? You have hydroxide ion on one side, but there's no hydroxide ion on the other side. So we are going to count the oxygen and hydrogen separately. Okay, now let's look for the most complex substance, which is going to be the aluminum sulfate right here. So we have 3 sulfate, 3. So that means we need 3 on the other side. So we're going to do a coefficient of 3, right? So that's going to be 3 sulfate. So that's balanced. And then aluminum, so we have 2. So we need a coefficient of 2. So we can get 2 aluminum. Okay, now we're good so far. So last, we need to balance hydrogen and oxygen. So how many oxygen do we have? There's subscript here for 3. So that means from hydroxide ion, from OH, you have 3 oxygen, but then there's a coefficient of 2 there. So that's 2 times 3, so you have 6 oxygen. All right, now, how about hydrogen? So hydrogen has a 1 also, so that's 3 hydrogen, but then consider that coefficient, so also 2, so also 2 times 3, 2 times 3, so that's 6 hydrogen. But again, don't forget the hydrogen from the citric acid, right? So that's also 3 times 2, so that's 6 hydrogen. So plus 6, sorry, I ran out of space. So that's going to be 12 hydrogen in total. So on the product side, we need to get 12 hydrogen and 6 oxygen. So how do we do that? Again, that's a 2-to-1 ratio, right? Which is perfect. So we just need to give it a coefficient of 6. So that's 12, that's 6. So everything is balanced. All right, and again, that should be 1, and you can leave it blank if you want to. Okay, hopefully you got all the practice problems correctly, and if not, hopefully you know where you got it wrong, and you will get everything right in the future. Okay, guys, I hope this is helpful. Let me know if you have any questions or if there's anything else that you want me to talk about.